Over the past few weeks, we've been working on solving systems of linear equations. We've solved them by graphing, by substitution, and by the elimination or addition-subtraction method. We're going to take a look at 3 examples and use some of those methods to solve the equations. Here we have Pat. He has 15 coins. They're all dimes and quarters, and the value of the coins is $2.55. The question is, how many dimes and quarters does Pat have? So my first equation is for the total number of coins, d plus q equals 15. My second equation is the equation that deals with money, the cost or the value of the dimes and quarters. A dime has a value of 10 cents, so 10 cents times the number of dimes. A quarter has a value of 25 cents, so 25 times the number of quarters, and 255 cents. Notice I did not write any decimals when I wrote this equation. The first thing I'm going to do is rewrite the top equation by multiplying the number of, or both sides of the equation by 10. This will allow me to eliminate the variable d when I subtract the 2 equations. So I'm going to have 10d plus 10q equals 150. Make sure you multiply both the left and right side of the equation by 10. And then the second equation, I'm not going to change that one at all. I'm just going to rewrite it under here. So we can see that we have 10d in both the first equation and the second equation. That means that when I subtract the 2 equations, the d's will cancel. Be very careful with your negative signs when you subtract. So we subtract, the 10d's cancel. 10q minus 25q is negative 15q. And then 150 minus 255 is 105, negative 105. And so I would divide then both sides of my equation by negative 15. And when I do that, I get that the number of quarters is 7. And since the total number of coins was 15, that means the number of dimes is 8. And you can do a real quick check here. We know that 8 times would be 80 cents. And we know that 7 quarters would be $1.75. And if we sum these two amounts, we will get $2.55. So we know our solution is correct. Let's take a look at another example. Here, Ann and Betty have $60 altogether, and Ann has 9 more than twice Betty's amount. How many does each have? So let's take a look at the equations. Together they have $60, so my one equation is a plus b equals 60. And my second equation comes from the second sentence. It says Ann has 9 more than twice Betty, so I add 9 to 2b. And then we're going to substitute 2b plus 9 in place of a, since we've already solved for a when we wrote that equation. So replacing a with 2b plus 9, I'd have 2b plus 9 plus b equals 60. And this is a pretty straightforward equation to solve. You would combine like terms and get 3b, and at the same time we might as well subtract 9. So I'd have 3b equals 51, and if 3b is 51, divide both sides by 3, we get that b is 17. So then I would either need to subtract 17 from 60 or double 17 and add 9. Either way, the answer we get is $43. So Ann has $43 and Betty has 17. Let's look at one last example. The sum of 2 numbers is 21 and their difference is 5. What are the numbers? These equations are pretty self-explanatory. Sum is 21, difference is 5. I'm going to combine the 2 equations, and when I do that, because we have y and negative y, those cancel. So I have 2y equals 26, and that would mean that if we divide both sides by 2, we'll get x equals 13. And if x is 13, substituting that back in to either of the equations, I'll substitute it in this one. 13 plus something gives me 21, and that something would be 8. And notice if I take x minus y, 13 minus 8, I do get 5. Just a quick reminder of how you could solve this system using Desmos. We'll go here to desmos.com, So our one equation was x plus y equals 21. Our other equation was x minus y equals 5. And let's see, we can't see the solution to this system, so let's zoom out. Oh, there we go. Now we can see the solution to this system. The solution to this system is 13, 8, which is what we saw earlier. We'll be taking a look at many more examples in class over the next few days.